Greetings and welcome, Internet friends. Mr. Waddy here, and I'm going over the homework on solving systems of three equations with three unknowns. And so here I've got a wonderful set of equations, and I'm going to solve using the elimination method. And so in order to do that, I'm going to get opposite coefficients for one of the variables and eliminate the same variable 2 times, giving me a system of 2. Right? And we know how to solve systems of 2, so it'll be great. So between the x's, I've got 1, 1, and 2. Least common multiple is 2. Between the y's, 1, 2, and 3. The least common multiple between those numbers would be 6. And between the z's, I've got 1, 1, and 2, which the least common multiple is 2. So I guess whether I'm going for opposite x's or z's, it doesn't matter. Although, I realize, no, they're both really equally convenient. So I'll just go for opposite x's. Why not? And so I'm going to have to multiply this top equation by 2. And I'll have to multiply the second equation by 2. And so I call these, by the way, equations A, B, and C. And so I'm multiplying these by some number, a constant, in order to get opposite coefficients so that when I add equations together, it eliminates a variable. And so 2 times equation A, 2 times x is 2x plus 2y minus 4z, right? I'm multiplying by these things. And don't forget to multiply the right-hand side as well, equals 10. And equation B multiplied by 2 is negative 2x plus 4y plus 2z equals 4. And so now I can combine these and see at some point adding pairs of them together in order to eliminate. And so since this equation, the 2b version, has the negative 2x, I'll add it to 2a and I'll add it to equation C to eliminate. And so here we go. I've got, let's do, we'll do 2a plus 2b as my first. And then after that, I'll do 2b plus c, because, right, I want to be able to eliminate the x twice. So adding these together, those get eliminated. I get 6y. I get minus 2z. Pardon my 2's and z's looking so similar. 10 and 4 is 14. And then taking 2b and combining with c, the x's cancel out. 3y and 4y is 7y. And let's see, what am I adding? This is why it's so important labeling, because it's like I could easily get lost. These combine to be a single z. And I've got 9 and 4 combines to be 13. And so notice the beauty of this is that I now have 2 equations and 2 unknowns. Something that I might remember from my Algebra 1 days. And so I sometimes call these my new equations D and E. You're welcome to label all of these equations your own letters, but whatever. As long as you have a system that communicates what you're doing in each row, because it's tough to realize this equation was coming from multiple things before it. Yeah, you can get lost with all of our variables in all of our rows. So let's solve this equation. You could choose, by the way, to go by substitution and solve for the z and go from there. Roll with it. All right, that's fine too. But I'm going to use elimination. So between 6 and 7, 42 is the number that those have as a least common multiple, and between 2 and 1. 2 is the least common multiple. So I'm going to go for opposite z's here. And so I already have negative 2z for equation D, so that's good. And to get positive 2z to eliminate it, I need to multiply equation E by 2. And so I'll have 2 times 7y is 14y, plus 2z equals, and 2 times 13 is 26. And so now notice the benefit here of having these opposite z's is that if I add these equations together, I'll eliminate it. And so I've got D plus 2e, like so. And so 6y and 14y is 20y. negative 2z, and 2z is no z's. 14 and 26 adds up to be 40. And so what's wonderful about this is that this equation has one variable in it. And so I can just solve, right, using my original solving strategy. And I get y equals 2. But I'm not done. I've still got to figure out what is x and what is z. What are those equal to? And so I'm going to do that by substitution. And so if y equals 2, notice if I could plug it into any of these three equations, whichever one I'd like, I could solve for z. And so it looks like this version is the easiest one. And so I'm going to plug it in here. Boop, boop, boop. And so I'll have 7 times y plus 1z equals 13. And so y was the 2. And so I'm going to just solve. 14 plus z equals 13. Subtract the 14 from both sides. So even though this is a little crazy, hopefully it's like a little bit comfortable being out of quadratics for a little bit and just like a bunch of old school solving, right? So I found z and y now, and so now I just need to find x. And so any of these equations have x's and y's and z's, so I could plug into either of those that I like. Now the one I happen to like the most is plain old equation A, and I like that because x won't require me to solve very much. And so I'm going to plug in this for y. I'm going to plug in this for z. And I will solve for x. And so here we go. I've got x plus y minus 2 times z equals 5. And so plugging in 2 there, plugging in negative 1 there. And so I got x plus 2 equals 5. X plus 4 equals 5. And then subtract 4 from both sides. And I get x equals 1. And so my answer is the XYZ combination. We call it an ordered triple, not an ordered pair. A pair would be two things. Coordinates, suggesting 2. All right, and so 1 for x, 2 for y, and negative 1 for z. So that's my ordered triple, the combination where if I plug in 1, 2, and negative 1, it will make each of these equations true, which at this point I'm not going to ask you to do a check. But to do a check, you would have had to plug it into all three, and it needs to work in all three of them. Ugh, no thanks. All right, here's equation or problem 6. And so let's do the same thing. Now you're welcome to investigate substitution. I would recommend substitute solving for one of those. We'll do some more in my next video. But we're going to do elimination. So between 3, 3, and 1, the least common multiple is 3. Between 2, 4, and 3, what is 12? 12, 2 goes into 12, 4 goes into, and 3, yep. And between 1, 5, and 4 would be 20. And so we're going to go for opposite x's. These two equations already have it. So what I would call equation A and B are good. And equation C, I've got to multiply by 3. And so 3 times Charlie is going to give me 3x. 3 times negative 3y is minus 9y. 3 times 4z is plus 12z. And 3 times negative 14, negative 30, plus 12, negative 42. Wow. Whew. Man, my mind. Whew. All right. And so now that I have opposite coefficients here and here and here, I'm going to eliminate the same variable twice. So adding equations A and B. So here's A, here's B. So I'm going to do A plus B will eliminate the 3x with a negative 3x. And then I'll add equation B to equation 3c, right? And so a negative 3x and a positive 3x will eliminate. So let's do a and b first. So 3x and negative 3x, no x's. 2y and 4y, 6y. Negative z and 5z, 4z's. 8 and negative 14 is negative 6. All right, now let's do b plus 3c. Boom, boom, gone. 4y and negative 9y is negative 5y. 5z and 12z is 17z. And let's see, let me make sure I get the right row here. b plus 3c. So negative 14 and negative 42 is negative 56. And so notice, by eliminating the same variable twice, now I have a system of two equations and two unknowns, something that we know how to solve. And so I'm going to use elimination on this. Between 5 and 6, they have a least common multiple of 30. Between 4 and 17, 17's prime, 68 would be the least common multiple. Also, once I have my two equations and two unknowns, I typically call this equation D and equation E, right? And so those are the same as that. And so I'm going to go for opposite x's. I'd have to multiply this top equation by 5. So I'm going to have 5D, and I'd have to multiply the bottom equation by 6. 6 echo. And so 5 times 6y, 30y. 5 times 4z, 20z. 5 times negative 6 is negative 30. And then negative 6 times this equation. So minus 30y. Let's see, 6 times 17. Don't trust myself here. Hundo dos. Plus 102z equals 6 times 56 of the negative variety is negative 336. So let's add these together. So 5d plus 6e. Notice the y's cancel out. That's what we were going for. I get 122 z's equals negative 336. Now, if I solve for z, plain old style, does it go? Does it go? Oh dear. Uh-oh, friendos. Now, this is a struggle. I'm getting a decimal, and although in real life, decimals happen, it's a thing, all right? I don't believe I'm supposed to get a decimal for this one. And so I'm beginning to be suspicious. Now, if I wanted to, I could plug that decimal back into z, and I could solve for y, and then I could plug in z and y in and solve for x. But I'm gonna do a quick check and see if I don't believe I gave you a problem. No, I'm not supposed to have this. Okay, and so now I'm gonna see whether or not I have a typo somewhere. All right, 6y plus 4z equals negative 6. I think that's correct. Negative 5y plus 17z equals negative 56. I multiplied the top one, 30. 5 times 4 is 20. Yep, negative 30. Oh, you know what I did? This is 3. Here it is. And you've probably been staring at it this whole time. These added to be 366. Boom, there it is. Divide both sides by 122. All right. And I get z equals negative 3. Aha, all right. That feels better. And so now to solve for y, notice back up here, or technically any of these four, if I plug in for z, I'd solve for y. I'm going to plug it into the one with the smallest numbers, so I'm going to plug it into equation D. Right. And so I'll have 6y plus 4 times z equals -6. And so I plug in the -3. 6y minus 12 equals -6. Add 12. 6y equals +6. Div 6. And I get y equals 1. And now to solve for x, I could plug in to any of these that had 3 variables. I could plug in 1 for y, -3 for z, and solve. Now I'm going to choose this one. And I'm choosing this one because x looks like it's the easiest one to solve for. So I'll plug in for z there. I'll plug in for y there. All right, here we go, wrapping it up. X minus 3 times y plus 4 times z equals -14. And I got 1 for y, -3 for z. So x minus 3 minus 12 equals -14. X minus 15 equals -14. Scrolly. Add 15 to both sides. And I get x equals 1. Nice. And so our ordered triple is x, y, z. There you go. I believe on the homework assignment, at least this year that I've been giving my Algebra 2 students, all of your problems will have answers, and all of them will have exactly one answer, and there won't be any decimals. Okay, so I tried to make it friendly for you. The next assignment is when we'll start having infinitely many or no solutions. All right, well, thanks for watching, internet friends. Have a great day. Adios.